Now we're going to try and break up some of the code that we've written into a more organized structure. Let's say we have a Java class that has lots of different instructions in it. Well, it's pretty easy for code to start getting very long and very complicated. So complicated that it's hard for us humans to understand everything that it does and maintain it and fix it when we need to. You can think of breaking up your code line by line and giving each of those sections of code a separate name as one of the different ways you can organize your code. This act of sectioning off your code and giving it a name is called a method. In Java, you can declare your own methods. They're similar to the main method in that they're a chunk of code that runs, but this time you get to name it. The way that methods work is you start with the word public, static, void, and then whatever you want is the name of your method. You get to make up the name. In Java, it's traditional that you start with a lowercase letter and then uppercase every word after it. This is different from class names that start with an uppercase letter, but they're still camel-cased. Then you add a set of parentheses and then a set of open and closed curly braces. Now you can put whatever statements you want in between these curly braces. Then whenever you're ready for that code to run, you call the method by name. It's kind of like making your own Java keyword. So you could imagine before that you had a class that looked like this, where you have the outer wrapper of the class, and then you have the main method with a bunch of statements in it, which can get kind of messy. Now, with methods, you can think of breaking that class up into a series of methods that all exist within that outer wrapper. So there's two steps in creating a new method. First, you have to define it or declare it with the syntax that we talked about: public, static, void, the name, a set of parentheses, and then a set of curly braces. And then you can put as much code in between those curly braces as you want. Now, adding this to your code isn't actually going to let this code run. In fact, you could add as many methods as you want, but if you forget the second step, which is to call them, that code will never get touched. You have to remember that Java only runs the code in the main method. So if you want your code in your own method to run, you have to call it in the main method. The way that you call a method is with the name of the method and then a set of parentheses followed by a semicolon, just like we have here. So let's say you have a class, and then within that class you have your main method, and then your main method closes with that closing curly brace, and then down here you have your closing to the class curly brace. Well, right here is where you're going to want to put your method. That makes it sort of on the same level as the main method, but still within the class. Then you can move whatever lines of code were previously in your main method inside the curly braces of your own method. Now, if we were to run this code, nothing would happen. But now, once we add this call, what's going to happen is the computer is going to jump to that method definition and then run all of the code inside of it, producing the output that we see here. Methods not only help you break up code, they help you reuse code. So we've sort of broken up our code as we can see here, but there's some things that happen more than once. So we can kind of think of this as being a set of 3 tasks, one of which we perform twice. Well, you could copy and paste that code over twice like we have here, or you could use methods to remove what we would call the redundancy. So what we've done here instead is we've taken all of the tasks and put them into their own methods, and then you can actually call each method however many times you want. In this case, we called that middle method twice, so that we still produce the exact same output, but we only had to type those lines of code once. This comes in super handy, especially because, as you can imagine, if you wanted to make changes to something, now you only have to make changes in one spot. The way that this works is that the computer is going to come in and it's always going to run the very first line in the main method. Once it does that, it's going to move on to the next line in the main method. And then it'll produce that line, and then it'll produce the next line, and so on and so forth. This top-down approach is what we would call the control flow of your Java program. Then it gets to that curly brace and it stops. So let's revisit our example here where we've got everything broken up into methods. How does this top-down execution work when it's all method calls in main? Well, now here, I'm going to start at the top of main, just like before, but immediately I'm going to jump to my definition of my method, and I'm going to run the very first line inside that method. So the method call essentially becomes a jump, like go find this definition and then run the code inside of it. Now it's going to move line by line within the method and run all of that until it gets to the closing curly brace of that method. Once it does that, then it returns up to main and continues on where it left off. So it sort of remembers where it was and then returns back to that spot and then continues again with the top-down flow. This is pretty straightforward, but things can get really complicated because what happens when a method calls another method? Well, it still follows the same procedure, but you can end up getting layers and layers of method calls. Let's take this code as an example. We're going to trace through the overall execution of this method. So first, we're going to call that first method. You can kind of think of this as a stack of papers, and in fact, it's called the call stack for a reason. Your code's going through and it's running your main method, and then it sees this method call, and it's kind of like it makes a new copy of that method, boom, puts it on top of the stack, and then runs all of the code inside this method, and then it returns back to where it was called, and then since it's done, you kind of throw that piece of paper away. Then you hit that second method call, and it puts another piece of paper on top of the stack, and it starts to run all the lines of code inside that. But one of those lines of code is another method call, and there you put another piece of paper on top. So you have to complete everything in this method call before you start returning back, no matter how many layers deep you are. So here we're going to run that piece of code, and then we're going to return back to the method call that we were in. We're going to finish that line, and then we finally return back to main. If you think about it how the computer thinks about it, that it's just very top down, and whenever it sees a method call, it makes a jump, completes everything in that method before it returns back to where it was originally called, it's pretty straightforward. Computers aren't creative. They're always going to run this way. But sometimes it can be hard for us humans to follow along. That's why drawing diagrams or thinking about the call stack as physical piece of papers can help make this a lot clearer.